Performing backups on your databases is going to be an absolute necessity. But when you start to put together the plan for how you're going to go about accomplishing this, you have a number of different backup types to choose from. And these give you the ability to customize a solution that allows you to perform backups faster and slower. And the general rule is the faster you can perform the backups, the longer it's going to take to perform the recovery process. The slower the backups are to complete, generally, the faster and more efficiently you can recover the database. Then there's ways to put all these various options together, land somewhere there in the middle. The bottom line is there are 6 types of backups that can be performed in SQL Server 2016. Let me give you a little disclaimer here. Depending on what documentation you read, who wrote it, humidity, and a bunch of other things, you will see sometimes 7 different types of backups, 8 different types of backups, but a lot of times they use different names to mean basically the same functionality. We're going to go with 6 types here because these are the ones were listed in the official Microsoft documentation. But if you understand these, you will also be able to talk intelligently in real world meetings and discussions about backups, backup plans, and so forth. The first backup type is the full backup. That's the one we all first learned about when we first started doing backups early in our career. Then there's the differential backup, the log backup, copy only backup, file backup, and a partial backup. Let's take a quick look at just the general description and purpose of each one of these. The full backup is the standard backup. Most of the time, when we back up small individual files, like we can back up an Excel spreadsheet, we just simply copy the entire spreadsheet and we can right click and copy it and paste it over to another location. Well, we just backed it up. That was a full backup. We got everything. With a database, a full backup copies all the database files, the file groups, the transaction log data, every aspect of the database, the structure, the schema, the data itself, everything that's required to recover the database gets copied in that backup. It contains the complete state of the database at the time the backup successfully finished. The good news with a full backup is that if I have a failure, I can restore the full backup and generally I'm done. I've got the database in the state it was in when the backup finished. And if I don't want to apply any more updates to that, I'm done. This is the fastest, most efficient way to restore data. Just get that full backup. A differential backup is where reality starts to set in because a differential backup captures only the data. We're talking about at the extent level. If you understand what an extent is, good. If not, don't worry about it right now. The bottom line is the differential backup captures only the data that has changed since the previous differential backup or since the last full backup. The bottom line on differentials, they have to be used in tandem with a full backup. Here's what we can do. We can take a full backup on Saturday night. This backup may take 9 hours. We get it Saturday night. Then when we open for business Monday morning, we run the business all day and then we take a differential backup on Monday night. It's only going to capture the data that's changed since that backup was completed Saturday night. We could take another differential on Friday afternoon. It only gets the changes that were made since the prior differential on Monday night. If we have to restore using this full backup and differential, then we're going to have to restore from the full backup and then apply that last differential because it's going to have everything that changed in a cumulative fashion since that last full backup. It takes a little longer to recover, but those differentials capture just the changes and they can happen pretty quickly. Sometimes you can do these on lunch hours, break times, and so forth, depending on how structured your environment is. A transaction log backup is really what we used to know as an incremental backup. It captures all the transaction log records that were not backed up in a previous log backup. Let me give you a little note here, though. Make sure you understand this. The ability to perform transaction log backups totally depends on your database recovery model. And we're going to talk about database recovery models later on in the course. If you're not really clear on those, just hang on. We'll get you there. A transaction log backup captures those changes that were written into the transaction log before they went into the actual database. So a transaction log backup, we can take one of those at 3 different places throughout the day. We can get a transaction log back up around 10 o'clock in the morning, around 2 in the afternoon, then one around 6 o'clock that night. We're getting all the changes and modifications to the database in each one of those, and every time we do a transaction log backup, we're clearing the transaction log out. If we have to restore from this, we're going to have to restore that first full backup, and then we're going to have to basically replay every one of these transaction logs in the correct order until we finally get back to where we were when that last transaction log was basically created. A lot of times you will hear the first thing you do when you arrive on the scene and there's been some sort of event is you want to back up the transaction log that's there because it has the latest transactions. Before you try to do anything else, get that last transaction log back up and then start through your restore process. And you can, a lot of times, get back to pretty close to the last transaction that was carried out before the event occurred. We'll talk about database recovery models and how it impacts transaction log backups a little bit later on in the course. Copy only backup. This is where a backup's performed. It just copies the data that's there, but it doesn't archive any backup bits or any archive bits that exist on files. Because keep in mind, I mentioned we can take a full backup and then we can do a differential. Well, how does the system know what's changed since the full backup? Anytime a data or file is changed, an archive bit is set. The backup systems can see a 1 there and say, this data has the archive bit set. It has been changed since the last time, or vice versa. Now that I'm in a live situation here, I may have that backwards. Bottom line is, it identifies files that have been changed, and so the differentials can pick that up. With a copy only, it just copies the data, but it doesn't set or reset any archive bits. It just grabs a kind of state of the data right now. And a lot of times we need this to create a copy of a database for testing and that sort of thing. It does not affect your ability to pull differential or transaction log backups at a later point. File backup is where we capture one or more database files or file groups. A close cousin to this is what's called a partial backup, and we capture data from selected file groups in a database. So as you can tell, you got a lot of options, and these are the 6 most common things. Again, they're the ones that are listed explicitly in Microsoft documentation, and there is a little bit of crossover like with file and partial. There are technical differences. Just make sure you're generally aware of these. Watch for these out there in scenarios on the exam, and just understand how they relate to each other, and you'll do just fine.